Hello, so today we are going to do max depth of binary tree. So basically this is part of Leetcode daily challenge. So we have a root of a binary tree and we want to return its max depth. And a binary tree max depth is basically the number of nodes along a path that have the longest path from the root to a leaf node, right? So just the longest path from a root node to the leaf node, essentially. So here, for example, in this first tree, we have 1, 2, right? And 1, 2. So these two have the longest path, right, from the root to a leaf. So we return 3 because we count the nodes, not the edges, right? So that's pretty much the idea. Now, how do we solve it? Well, this is actually a pretty easy application of DFS, right? What we can do is each node, right, is going to return to the caller its depth, right? So for example, we go all the way here, right? And when we reach this last node, it returns to its parent that depth of 1, and then this one. Okay, so how do we solve it? So with DFS, what we know is that we go all the way until the leaf, and then from there the leaf node returns a value to the parent, and we keep doing that all the way until the root, and that's what we return. So that's what DFS does, right? So that's exactly what we want to do here. So what should we do when we reach a leaf node, or when we reach null? So when not node, what should we do? Well, there is no node to count, so obviously we want to return 0. So you can think of it like this here gets 0, this node gets 0, this node gets 0. Because they are leaf nodes, they're no children, so we get 0. So since in the problem we saw that what they want is the path to count the number of nodes in the path. So each node that is actually not nil should add 1 to the path, right? So what that means basically is that this node here is going to return 1, right? Plus whatever are the number of nodes in its children. And since this one doesn't have any children, it needs to just return 0, whatever it got from here. So this will return 0. Same thing here, 1 plus 0. And so this one here, the 2 has both 1 from the right side, and 1 from the left side. Since we just want the maximum path, so let's say we have nodes like this, and this one is a big tree, but this one is just 1. We want to take the length of this one. So what are we doing that way? We basically take the max of the length of the left side and the length of the right side. So that's what we are going to do here. This one is going to say max of 1 and 1, and since that's 1, it's just going to add itself. Remember, each one of them takes its own value and then adds itself, and so it's going to add itself, so it's going to add 1 plus 1. Okay, this one, since it has 0, it adds itself, so it returns 1 plus 0. So now 3 has two things: has the left child that is returning just 1, and has the right child that is returning 2. So it needs to take the right child because it's bigger, so 2, but it needs to add itself, so 2 plus 1, that's 3. And now that we are done that way, we return 3, because again, DFS, we do all the children, and every child gives the result to its parent, and then all the way when we get to the root, we return the result. And so that's how we do it here. And so what's the formula we are using here? Well, it's just basically we do if not node, we return 0, but then for the rest we just do 1 plus the max of DFS on the left side, right? And then DFS on the right side, right? That's exactly what we're doing here, and that's what the DFS on the node returns. So that's the way to do it with DFS. It's going to be O of n being the number of nodes. We can do it also with iterative DFS and iterative and BFS. We'll see that solution, but first let's write the recursive DFS solution. Okay, so now let's write our recursive DFS solution first. So what do we need to do? We need to we need to just define our DFS function, right, on a node, and that's what we're going to call with the root. And here, if not node, we want to return 0, and then we are going to call for node.left and for node.right. Okay, and what we said is we want to take the max, right? And then we want each node to add itself, so the current node will add 1 for itself, and that should be it. And that passes our test cases. Okay, so that's the recursive DFS solution. Now let's do iterative DFS. So iterative DFS is pretty similar, right? Except we use a stack instead of relying on recursion. So for our stack, we'll start, of course, with the root in the same way that we started with the root. And we are going to say the depth is 1. So this is to account for the root value, right? And so we will go through the stack, and we will pop from the stack just normal iterative DFS. And then here we have both a pair of the node and the depth, right? And so that's what we get here. We get the depth. Okay. And now we are going to go through the children, right? So for child in node.left and node.right, we are going to check if the child is actually a valid node. It's not none. We can add to the stack. So this is the same way that we are iterating here over left and right. That's exactly what we are doing here. And so we add 1. This one we added. We are going to do it here. When we add to the stack, we will increase depth by 1 to account for the child node. Okay, so same thing except using a stack. Same logic. And however, to do this max here, we need to do it somewhere. So either we do it here with the depth plus 1, or we can do it here, right? So this is going to be a max depth for similar to what we are doing here. Is going to be just the max of max depth and the current depth, right? Okay, you could also do it here if you want, but here we are doing it so that we can handle if we have just one node in a tree. Okay, so we don't need to return at the end. We just need to return max depth, right? And that should be it. Except we need to define, of course, max depth, right? It needs to be 0. And we can remove this. Now, there is one problem, which is what if the root node is null? How do we handle that, right? Well, we can just do if not root, return 0. That would be a quick way to solve it. So let's just first try this. Okay, so that passes. Now that's the DFS, iterative DFS solution. We can also do BFS in a similar way like we are doing here, iterative DFS. So yeah, let's just code BFS solution quickly here. So BFS solution, we need the level. So we have root and 1, and we need the max depth, of course, similar to what we did with DFS. And we'll go through the level, each level. And in the same way, we will get the depth, and we will just go through the level. For the next level, we need to keep track of it, right? And in the same way that we did with iterative DFS, let's just handle the none case separately to make it easier for us. And for max depth, we'll start with 1 because if the root is none, we want to use max depth. If the root is just one element, if the tree is just one element, we want to use value of 1. So here, this is the next layer or the next level. And so for each node from the current layer, we'll go through its children. So left and node.right. And then for each child, we want to add it to the next level. So append child and depth plus 1. And then we want to assign to the level what's in next, right? And then at the end, of course, we want to return max depth. But we also want to take the max at some point, right? And so let's just take it here when we get this depth value, similar to what we did with DFS. And so it's just going to be the max of that in the current depth. And that should be it. This needs to be 4 because it's 2 elements here. And so that should be it. Let's run it. Yeah, so this is BFS where we do it level by level. And you can see here, this is the first level, and then we assign that to next. We add the children to next, and then we make those children the next level. And we keep doing this until the end. Let's submit. Okay, so that passes our test cases. Yeah, so that's pretty much it for this problem. I think we did 3 different solutions. Please like and subscribe, and see you on the next one. Bye.